In this presentation, we're going to look at integration, and what we're going to do here is use a special technique called partial fraction expansion. Now, we're just going to sort of first off look at this expression here, integrate this. 5x plus 17 divided by x squared plus 7x plus 12. What you might notice here, essentially what you might try out here first off, before I go into anything, is that you might try out substitution technique. Or, this might be the first port of call for something like this sort of technique. And letting u equals x squared plus 7x plus 12. And what you are looking for there is to get something that cancels out with 5x plus 17. But if you go down that route, you won't find something that comes easily. So that's not going to work. But what you should notice actually is that you have a quadratic expression here, and in this situation what you could try to do is factorize it, working that out. That is x plus 3 times x plus 4. Okay, that's the denominator re-expressed as two simpler terms, or the product of two simpler terms. That is helpful for a particular reason. What we're going to do is try and split up this expression into two smaller terms. So the general structure to this is the partial fraction expansion technique, by the way. So a over x plus 3 plus b over x plus 4. Essentially what we're going to do is try and reconstruct what we have here on the left hand side as the sum of two simpler expressions, a over x plus 3 plus b over x plus 4. What we have to do here is find out what a and b are. So what we're going to do is sort of work backwards a bit. What we're going to do is sort of cross multiply a and b, or a over x plus 3 plus b over x plus 4. So working that out, we would have a times x plus 4, plus b times x plus 3, this is cross multiplication, all over x plus 3 times x plus 4. Okay, and that is still equal to 5x plus 17 over x squared plus 7x plus 12. Okay, now the thing about this is the denominators, we already know that the denominators are equal to each other. So this is equal to this, okay? Though the denominators of both sides are equal to each other. So necessarily, the numerators of both sides are equal to each other. Okay, so we're going to disregard the denominators from now on. I'm just going to take out of the play and just look at the numerators of both sides. Okay, so that's it there. So 5x plus 17 equals, we can re-express this as ax plus 4a plus bx plus 3b. Okay, that is equal to 5x plus 17. Now, what I'm going to do is actually, we have a group there for both sides. What I'm going to do here is I'm going to rewrite ax plus 4a plus bx plus 3b. I'm going to re-express it. I'm going to regroup it. I'm going to have all the terms that have x here. So we have ax plus bx. Oops, my pen's not working. And then we have the other terms that don't have x, 4a plus 3b, and we're going to group all of them together. So what we can do here, so there we go. So group them all together, regroup them essentially, ax plus bx plus 4a plus 3b. Now necessarily, ax plus bx, I'm going to re-express that again. That's a plus b times x plus 4a plus 3b. Okay, and that again is equal to 5 times x plus 17. So what we're saying here is that 5 is equal to a plus b, and 17 is equal to 4a plus 3b. Okay, so, gone too far there, sort of spoiled all the fun. So what we're going to say here is we're going to re-express this. A5 equals a plus b. So that means that a is equal to 5 minus b. Subtract b from both sides. And what we're going to do is substitute it back into that. So we have 17 equals 4 times 5 minus b plus 3b. That is equal to 20 minus 4b plus 3b. That is equal to 20 minus b. So 17 equals 20 minus b. Therefore, b is equal to 3. Okay? And necessarily, a is equal to 2. A is equal to 5 minus 3. So the a is equal to 2. Again, where did that come from? Just remember we said this earlier on. Okay? So, what we're going to do is we can re-express our expression like this. So we have two simpler terms. Now, this is the original integral. We have a and we have b, 2 and 3. And this is a very simple calculation now. So what we're going to do is get the integral of this part here, 2 over x plus 3. Well, we're just going to leave out the 2 out of it, and the integral of 1 over x plus something is the log, the natural log of x plus 3. Likewise, 3 over x plus 4, that is equal to 3 times log of x plus 4. And at the end we have the coefficient, the undetermined coefficient, plus c. Okay. Now, as a remark, you could use rules of logarithms to proceed. So maybe use, but as far as I'm concerned, this is far enough. We're good, we got our job done. The rest was just using rules of logarithms. Not really part of the integration exercise, so I'm going to sort of, essentially as far as the integration is concerned, we're finished. So that's the answer there. 2 times log of x plus 3 plus 3 times log of x plus 4 plus c. And just as a remark, if it's an indefinite integral, in this case it's an indefinite integral, remember the coefficient, the undetermined coefficient. Alright, that's enough of that.